I was classically trained as a composer. I also had a strong interest in technology. I've always made recordings and started in my early teens with various radios and my record player, and experimented in recording bits and pieces onto my tape recorder. And I also had an interest in electronics and how all this technology works, and I used to make little radios out of parts. I used a kit that I got for my birthday. So in my work I aim to find connections between music and sounds of the environment, be it sounds of nature or human-made sounds, factories and cars, and anything that is remotely interesting from a listening perspective. I always experimented with the material afterwards, and that's sort of the beauty of it, that you can play it back and take it apart and put it back together in a different order. Through my early interest in electronics, I became really fascinated in microphones. Microphones are the membranes between the world out there and what ends up on your recording, be it your tape or your digital recorder. I went on the artist residency on the survey on the Celtic Explorer in September-October 2018, together with the C-Size team led by Sergi Lebedev of the Dublin Institute of Advanced Studies.
In seismology, we record vibrations of the Earth caused by seismic waves propagating through the Earth. In a way, that's the sound of the Earth that come from different sources. Some of these sources are earthquakes, other sources are ocean waves interacting with the seafloor and continental shelf, and wind, waves, and people and animals cause more seismic waves to propagate. And it all parts of the ambient noise wave field that we can observe. We record these waves using seismometers. That's the devices we fix on the surface of the Earth, and that's how we measure seismic waves. If we want to do that on the seafloor, that's a lot more challenging. So these devices are sophisticated gadgets that can withstand enormous pressures at the seafloor at the depth of a few kilometers, but at the same time they're very sensitive. They can record vibrations as small as nanometers and in a broad range of frequency, from many hertz, many cycles per second, to a few minutes in period. The project C-Size, in this project we have collected a unique data set. This is the first time anybody deployed successfully a large network of ocean bottom sensors over a broad area, a large part of the North Atlantic. We traveled in total over 5,000 kilometers deploying the network between Ireland and Iceland and the mid-ocean ridge. And now most of these instruments have been retrieved with 19 months of continuous data, which is quite unique and contains lots of new data with lots of new information on earthquakes in this region, on the structure of the Earth under this region, and on the sea creatures that live in the ocean. Broadly, the seismic data contain three types of signal. One type is geophonic, the sounds produced by the earth. So earthquakes are one major type of the signal, and we can record earthquakes close to the seismometer nearby and earthquakes very far away on the other side of the earth. The seismometers are very sensitive, they register earthquakes anywhere around the world. Then another type of earth-generated signal is the continuous noise produced by seismic waves interacting with the sea floor. That's the microseism that at a period of a few seconds can be seen continuously on any seismogram. And then the wind, the waves, the trees, anything produces, any motions at the surface produces some seismic waves at different frequencies that we can record, analyze, and sometimes even use to image what's under the surface inside the earth. Then the other major broad type of seismic signals is biophonic. That's the type of signal produced by living creatures. On the terrestrial stations on land, it's not very important, and we don't usually pay attention to those, but in the sea, on the seafloor, that's a large part of what we record. And finally, the third broad type of signals we record are anthropophonic. That's the type of signals produced by humans and human activity. In the sea, this would be commercial ship traffic, the fishermen boats, and seismic surveys in seismic exploration near the coast.
This was my first extended time at sea. I had been on ferries before and on day trips on smaller boats, but never really on a working ship for 2-3 weeks.
I think when we first heard of this, that we'll have an artist on our ship, we were curious and open-minded, and perhaps David was as well. Nobody knew what exactly to expect. And in the end, it was very successful on many levels. We found that, first of all, we had a lot of technical expertise that's complementary, that we could learn from each other and share, and that worked very well. But also the perspective of basically listening to the earth in broad sense, that's what we all do in our different fields and with our different ways we do this in our jobs, but we can certainly learn from each other. And with David being there, he attracted our attention to something that surrounded us, but we perhaps didn't focus our attention on before. The sound of the waves, the sound of the ship, the sound you hear when you put the microphone in the water overboard. There is some magic to all those sounds that is easy to miss, but if we focus, which we did thanks to David, that was a very interesting experience.
I was very excited and I prepared myself for the worst. And indeed, we hit some pretty bad weather with very high winds and waves. And this started pretty much on the first day and carried through most of our journey. this came as a bit of a shock to my system. I didn't get seasick, luckily, but it was very challenging to try and adjust every part of my body to the constant motion aboard the ship, and it was hard to keep your balance at first, and very simple tasks became suddenly very difficult. In the rough sea, it was hard to sleep, and the waves would literally lift you out of bed and then push you down back into your pillow, and it was a momentary loss of gravity. So being on the vessel out in the ocean during the storm really gave me a better understanding of what life at sea is about. The crew and the captain were talking about the confused sea. It is when the swell of waves moves in one direction and the wind into another. It's quite a weird sensation. It's very erratic, the pitch and roll, and it eventually dislodges your balance and your groundedness. This constant physical experience heightened my perceptions of the sound on the ship. I made many hours of field recordings of wind and waves, and I made some underwater recordings, but also recordings of the sounds of the ship itself. I had brought highly sensitive contact microphones that I touched to different parts of the steel structure of the ship, and you get a very interesting listening experience. It's almost being attached to the hull of the ship and feeling its rumbles and the agitation that happens. The wind was howling and whistling through the poles and cranes, and there were big clangs of sort of rogue waves which hit us on the broadside, and it sort of excited the steel structure almost like a bell. There is something about sound that allows us to experience the physicality of our environment. We hear not only with our ears but with our whole body, and attaching microphones to the body of the ship helps me to convey its physicality to the listener. So in April, May this year, the seismic data was recovered. The ocean bottom seismometers were brought back up onto the ship. Unfortunately, I was unable to join during the recovery mission due to the pandemic situation.
So this new data will reveal something new about the seismicity earthquakes in the region. It will tell us a lot more than we know now about what's inside the earth, and that is very interesting because it relates to the origin of spectacular volcanoes in Giant's Causeway, for example, or offshore Ireland. There are many extinct volcanoes similar to the Giant's Causeway. The origin of those is unclear, but once we know what's inside the earth between Iceland and Ireland, we may be able to find out what sort of flows of the hot material in the earth have caused these volcanoes. Seismograms are recordings of the sounds of the earth, typically at frequencies that are too low for the human ear to hear. But nevertheless, they are sounds of the earth, and in the old times, a typical seismic observatory practice would include listening to tapes of the earthquakes accelerated so that the signals would be audible. And the seismic analysts would listen to continuous recordings through the day and pick up any unusual signals. And then if something unusual happens at one station and at another, and it is confirmed, then they think it's an earthquake, and then they go and examine it closer. At the moment, we have computer programs that analyze these signals and do the job. So nowadays, it's not so common for analysts to listen to this, but this just shows that basically we are listening to the sound of the earth, whether it's with computer program or with the old-fashioned tapes. So the sound of the earth, studied by seismologists and thought of and imagined and transformed into art by an artist, it's still the same sound of the earth that we are all listening to and trying to understand.
Before I had received the actual data from these units, I had experimented with sample data, and I developed a system for sonification of this seismic data. Listening to seismic data requires playing around with the playback speed because most of the seismic events are well below the human hearing range, and so you would speed them up to various degrees, play them back at a factor of 30 times or even 100 times or more to discover different seismic events contained within this data. I really like this aspect of manipulating the time, and I ended up making it a feature in the finished work.
Well, we seismologists are used to certain representation of our data. We see seismogram, we see spectrograms, various technical ways of looking at it, not to mention computer programs that go through very large volumes of data. But listening to them with our own ears, that's certainly a different perspective. that makes a profound impression on you, first of all, when you hear signals from a few seismometers from different components. This rumble, powerful rumble of the earth that we can describe with our formula, but when you hear it, that's certainly a more tangible way to perceive it. And not only this is spectacular and impressive, but I think we can also discover new things with it, that with this way of looking at data than the conventional ways that we are used to. Especially with the seafloor data, it's still a relatively new technology, and arrays of seafloor seismometers, there have been a few around the world, but not so many. So we're still learning what is there. And well, there are earthquakes, we know those. There are ocean waves and how they interact with the seafloor. We are still learning the mechanism of how this works. And then there are whales that we can hear songs of, and then there are animals perhaps that interact with seismometers, bumping into them. So, and then there are of course ships and all kinds of human anthropogenic signals that add to the complex picture. And we are still trying to understand how the soundscape, all the different parts of the soundscape, what goes into it. So listening to all these signals, that's an amazing experience that lets you feel sort of in touch with what's happening. But also it's interesting, and we think it may let us discover something we didn't know before.
The piece I made for Aerial Sparks is called Palace of Ships. It manifests as an immersive sound installation, and it consists of the recordings I made on the ship, sonifications of the seismic data, and also a reading of an old Irish poem I came across along the way. The poem is about sailing through a storm, and I was immediately drawn to that because it brought me back in a way to my own experience during the artist residency, and I discovered the poem a few months later, and when some of the memories had already faded a little, and but it brought me back to this experience. I spent some time with Professor McMahuna, who helped me develop a pronunciation guide for the poem, and he was able to give me a notated version in phonetic notation. And Paddy Salmon, a friend and colleague of mine, was able to record some readings of the poem for me, which I used as raw material in the piece. In the same vein as treating the seismic recordings, I also played around with the voice recordings in terms of manipulating the speed and pitch at which the poem was read. This poem is written in a particular meter. It's called rocking meter, and it is to sort of mimic the motion of the waves, and it goes down, da dum, da dum, da dum, dum, da dum, da dum, da dum, and this comes out very strongly. And through slowing down these voice recordings, I was able to play with this meter a bit, and I found that it worked very well together with the recordings of the sea motion and the waves and the ship motion that I recorded. The seismic array deployed by Sergi and his team recorded over 19 months of data, and so there was really a plethora of material to choose from, and I ended up picking 3 days of data. One particularly active day from a seismic point of view, that was sometime during July 2019, and one day with a tornado which had formed over the Atlantic and ended up sweeping over Ireland on the 15th of February this year. Some people may remember this. And the third recording I picked was a particularly quiet day during April, and this would have been toward the end of the pandemic lockdown. And it is remarkable that there was a very little human activity audible in this recording. For those who get the chance to experience the installation on the island of Inisheer this September, I translated this composition onto a multi-channel audio system. I'm using ambisonic surround sound, and I'm trying to impart the physicality of my experience on the ship and combine it with the sonifications of earth vibrations, and which I translated from the seismic data. Seismic data seems to lend itself perfectly to this ambisonic format, as it is inherently spatial. You record a pressure component and then a vertical and two horizontal components. I also included some video footage I took during the survey, and these are really small vignettes, mostly taken at night when I couldn't sleep and I had to step out on deck, and I would focus in quite tightly on an event. The ship motion in combination with the movements of the sea itself. I'm really trying to convey a sense of loss of equilibrium, a lack of balance perhaps, and a state of uncertainty. The space we're presenting this in is a handball alley. It's a large enclosed hall, usually used for sports, to play handball. It's a very popular sport in Ireland. This seemed to be a very suitable space for this project, not only due to the fact that it is quite reverberant, and but it also it doesn't have any windows, and so you can enter the space and you can leave the outside world behind and spend some concentrated time listening and experience Palace of Ships.
Scientists and artists are alike, and they work alike in many ways. Our job is to create and discover new things that were not known or didn't exist before. We want to develop new methods how to do things and how to find out, discover new things. and that's how art and science are similar. There are of course differences, but this basic orientation, the basic drive to discover and create new things, that makes it very easy for us to operate together and to work together. Within science, creativity is very important for discovery. Once we discover something, the new knowledge has to be proven. So there is a rigorous process for validation and proving the results. But getting a new idea, that's magic that has no rules to it. In that, science and art are more similar than they are different. I think what we have experienced in our collaboration with David was very successful. We didn't know how it would work out, but it was fantastic. It was very successful in terms of technical exchange of ideas and competencies. And we just learned something we never knew before. We learned new perspectives, and I feel that our collaboration only started. Just now as we go, we discover new things and we develop new things. So it's very promising, and it's real, it's alive. That's fantastic.